All right, thank you everyone for coming to BSides. Hope everyone enjoyed the lunch and saw John's tool there, the SSH grabber. That's pretty fancy. But I would like to introduce our next speaker. We are getting started a couple minutes early, but that's okay. His name is Tal Melamed, and he's the Director of Security Research at Protego. So welcome. Thank you.
Thanks, everyone. Can you hear me? Right. Okay, so hi, everyone. Thanks for coming. My name is Tal. I just moved to Connecticut from Israel and Italy. I did around. So I've been in the Israeli cybersecurity industry for a while. I worked for companies like RSA, Checkpoint, AppSec, CNAC. And more recently, I just moved to New Haven, Connecticut. So the weather is different, so I got cold. And thanks for having me. Nice seeing all the Connecticut security scene here. So I specialize in application security. Started 15 years ago with web application, moved to client, mobile, IoT, and now serverless. But what is serverless, we'll see in a second. If you would like to follow me, I'm pretty active on the social media. Currently, I'm the director of security research at a company called Protego Labs, or Protego. We're a serverless security company, startup, based in Jerusalem, Israel. And we have a serverless security solution. Well, I won't show the product, but we'll talk about it in a second. Right, so let's start with what the hell is serverless. Does anyone here heard about serverless? 1, 2, 3. Okay, that's about what I thought. So pretty much no one knows what serverless is. So any of you actually wrote like a Lambda function or something like that? No, okay, 1. Yeah, we have a winner. So as you see, no one really knows it. I'll start by explaining what it means. So if back on the 90s, or even before that, we started with on-premise application where we took everything and had it on the site. Then we move on. I won't go through all of them. You all know that. I'll make a quick stop on the containers where everyone heard of, and see that when we moved to containers, we could eliminate all the need to control operation systems and virtualization and provisioning, and of course the networks and the service. It all came in that box called container, but we still needed to patch it, to set it up, to see what's inside, to know how to scale it, and it's still a lot of DevOps or a lot of operations, and also security. So we moved to serverless, which is kind of new, just introduced first in 2016 by AWS. We got technologies that allows us to write code, and that's it. Maybe just a few configuration requirements. So how many memory do you want for the function, etc. But that's it. So it allows companies, and especially startups, that has an idea to come right up, write code or their application logic, and have it launched in a few days, not having to deal with anything related to scalability, monitoring, patching, or anything like that. So the cloud providers already take care of that. All you need to do is write your code. Okay, what is serverless? Who are the providers? So all the big companies, this is why we know it's a thing, because Azure, AWS, Google, SAP just joined, IBM with OpenWhisk, and some other companies now allow that. So they are the infrastructure providers, and they have their console or their APIs to just come up, write function, write code, and launch your application. Who are the early adopters, or the first adopters of the technology? So we have some big companies. So Netflix is very strong on that. Expedia with all their sub companies. Also, Capital One Bank, one of the biggest, Coca-Cola, iRobot, The Zone, and some more big companies that you see that it's a little tough to move. I mean, there are a lot of startups that starting with that because it's easier to just start with it. But it's a little tougher transition to move to serverless because you already have your servers. You need to refine your code and do some changes around that. But there are some big companies that are doing that. Also, this is also how we see that it goes further. So this is a Google Trends graph. Let's show it here. Sorry, 1 second. Okay, so if we start back then in 2016, we can see that it has a graph that goes up, but like always, even if it's a new technology, and we thought that we've learned from past experience, I'll just type, serverless security. Right. So, right. No one, and probably that is me doing the research or something like that. So we have like 1 or 2 here, right? But just to make you understand how new is serverless and what are we doing here, I'll just write Docker here. So like the biggest container thing, and we'll get thing in perspective, right? So containers, right? Everyone goes with containers. Serverless, we just started. So we see us as ahead of a curve. This is what we what we see from customers and people that would use serverless in general. They're just experiencing with it. There are some companies, as I showed, that are already all in, but most of them are just experiencing with that technology, thinking about moving it eventually, but they're just starting with a small project and see how it goes. Okay, so what are the serverless basics? Why move to serverless? So apart from what I already told you, so the infrastructure scales for 0. You don't have to deal with anything, right? So everything, the infrastructure is built in. You just need to know how to use it. Also, one of the serverless basics is that you pay only for what you use. So you can write up an application, up and running, and if no one ever uses that, you don't pay a thing. You pay only for the invocations of your application. So suddenly there is some traffic into your application, you pay a few cents for every call, and when it goes higher, you probably start seeing more of your payment increases, but also your application traffic. And this is how it works with serverless. Okay, so the architecture, as I mentioned a few times, so you actually go and write functions like code, but they are called functions because each of them is supposed, or the architecture allows you to, is intended for microservices. That means that you go and you write simple codes on each of the functions. So also functions can only run for up to 15 minutes or 5 minutes, or depends on the infrastructure. So you write a short code that this is the specific of what this function needs to do, and then you start building your application with hundreds of functions and services and resources. It's not only functions. You can use databases, cloud storage, etc. And just I'll mention, it's called, maybe you heard of it, it's called Ephemeral and Stateless. You probably heard of it, because each function, when it goes up or when it runs, it has no notion of what's going on beside, on the application level. So it is really stateless. It knows nothing about nothing. It just runs, does its job, and then dies. So the ephemeral means that when the function or the code finishes to execute, it just dies. And the container that was loading this function, so you don't have to deal with these containers, it's managed by the cloud provider, but it dies with it. So there is no after function, before function, it's just the function, what it does, and that's it. And the operation also is one of the reasons that people move there, that companies move there, because it really minimizes the DevOps. And we will talk more about the security aspect of it, but it's imagine that you don't have to deal with anything related to infrastructure, so that gives you a very high velocity of your development. Okay, why does security here any different? We'll read about it. We'll talk about it in a few seconds. So let's do a quick gap analysis. Right, so what are the cons? There are no servers, so now I'm talking security, right? I just moved from what is serverless to security. There are no servers, so where do we deploy things, right? We want to monitor the network. We want to scan it. We want to put a firewall. We want to put an IPS, IDS, whatever we want. Where do we put it? We can't because it's not ours. So this is a kind of a con. No perimeter. So if we were talking, if we think of what we know of the traditional application, the monolithic application, we know it could be any type of network that it uses, but usually it just goes one way. So it could be HTTP, TCP, any proprietary network, but it always comes from the client to the server through that port or the network interface. But in serverless, that is gone. I mean, it's not gone, but it's just one out of many. So serverless, one of the things about it is that it allows you to run functions based on events, and the events could be anything. So it could be emails received, it could be a file that was uploaded, a line in a specific table that would change, will trigger your functions. Where do you put your security control, your network control between those? You don't control the network between the email. There is no service, so the email service or the database service, so DynamoDB or cloud storage, so Azure Blob or S3 bucket. You don't have that security, the network between them, so you don't control it. That gives us more complexity because the application architecture is different. You don't have one way in, you have multiple way in, and everything triggers a new event or new code in your application. And the high velocity of the development makes it even harder for the security persons to cope with it. So imagine that, I don't know, like a dev team wrote a feature, and now you want to test your firewall against it to see that it matches but doesn't do much of false positives. So it takes a few days, maybe in staging. But here the velocity is very, so every developer on its own writes its own function. How do you deal with 100 different functions that triggers different or have different entry points in one day or a week or, I don't know, your development, your cycles? So that makes it hard. But there are many pros. So yay, no servers. You don't have to deal with that anymore. So yeah, every time I had an idea and I wanted to write up code, I thought, oh, now I need to buy servers. I don't know, so make sure that it's okay. How do I scale it? So you don't have to deal with it anymore. So the fine-grained is, as I said, the architecture is built for microservices. This gives us a really, if you think about it, a really fine-grained of what each function should do in your system, not only in terms of code, because you don't look, the security person or the security manager doesn't have to understand what each function does, but it could. You have a limited, like, you only, right. The security person doesn't need to know what the function is doing in terms of code, but they can understand what is the function doing in the system. So it could also help you fine-grain your application and make your security tight your security about it. Transparency. So if you have, like, you download a container image and you don't know what's inside, you know what you need, but maybe there are hundreds of things, services, and ports open besides it. So I don't know, like SSH or whatever. And you have to look for it and see that you don't have backdoors into your system or open ports that you don't need. But here, it's different because you don't need to deal with that. You know that you need an API gateway, so you have an API gateway. You need a DynamoDB table or any other database or a cloud storage. This is what you get. You don't have to look for other things because you don't deal with any type of container. You just deal with the code. Right, so there are a few big challenges, and we'll discuss a few of them. Right, so let's take an example, a code example. It uses, this code uses AWS, which is the biggest service by far, biggest serverless provider, but it could be anything else. So what this function is doing is very, very simple. It reads a file. So it is triggered by an event, let's say, of a file uploaded or a file create. And it goes to the bucket that triggers it, takes the file name, and reads it. Right? Doesn't matter what it needs to do. So I talked about fine-grained application or fine-grained security. So let's see the process of what we could do in make it fine-grained. So the first stage, you'd go, okay, your developer wrote this code, and you go and tell him, right, but you need to provide a permission for this specific, oh yeah, I mentioned to say that. So you need to provide a permission for each of the functions separate. That makes it hard in one way, but could allow you to fine-grain it to a very tight attack surface. So you tell your developer, hey, go read the documentation and bring the right permission for the function. So the developer goes to the AWS examples, which is actually what it is, and brings this, okay, I'm gonna give this policy to the function. And what this policy means is that it allows the function, right, this is the permission of the function, to use any S3 any action inside an S3 service, this one, and the wildcard means everything. So the action could be file upload, file read, change permission, downloads, rewrite, delete, whatever you think about storage. And it allows everything to do everything. And this resource also is a wildcard, also great. It means that the function can do anything to any cloud storage in the account. So imagine that you have, I don't know, like one, I don't know, let's keep it small, like 10 cloud storage that your application deals with. And this function can do anything, including deleting them or changing the permission, making them public, to any of these cloud storages. That means that if someone managed to hack or to have to exploit this function, they can do really big problems into your application. We'll see later how it really goes. So you go and say, hey, what is this? Bring me some security into that. So the developer goes and takes this, reads further and say, hey, I only need to deal with a specific bucket. Why do I need the wildcard? And he say, oh, I found a solution. So now I will allow this function to do everything, but only to this specific bucket. So the function cannot, by the infrastructure, so you didn't have to deal with it, now cannot deal with any other cloud storage. That means that even if someone exploited the function, they cannot do anything to a different cloud storage. But that's not enough, because you're a security person. You say, why do you need to delete? I don't know, why do you need to have to be able to delete the function or upload file? You just need to read files. So go ahead and you find the best solution, which is this, list privilege. Only get object for this specific bucket. So even if the function is exploited, you can only read a file from this bucket. So that's great, but how do you do that for hundreds of functions every week? So what you really going, and this is just one simple event. S3 is very common. There are hundreds of services and about 5,000 actions in total. So how do you dig into that and find the specific action to all of it, to everything? So yeah, the only solution that we see is automating it. So yeah, I won't show it, but we provide an ability to automate that. If you're interested in that, come to me later and I'll discuss it further. Another challenge is, as I said, the velocity gives you hundreds and thousands of resources into your account, how do you deal with all of the security? So you need an observability, and this is the solution here is to know how to use all the infrastructure or the service provider resources. So there are logs, and there are I don't know, there are reports for everything in graphs and metrics, but you need to know to use them in order to understand what is going on into your application. Okay, let's talk about another challenge, which is big. We mentioned no perimeter, so no one perimeter. So monolithic application, everything came from one point in serverless. You can, so imagine this is some kind of a simple application architecture. The attacker can come from the API gateway and trigger your function, but they can also upload a file to the S3 bucket or any cloud storage, which will trigger a function, and they can also write something that will be written to a log, which will trigger a function. So eventually, you don't know where is the entry point for the attacker. It could be anything in the application, and you need to worry about that. So what we do is we give you both security and observability into your account so you cannot put a firewall, right? So how do you protect, I don't know, SQL injection, cross-site scripting, or fast traversal, or any other attack? How do you protect it? So the only way that we see to do it is to run the protection inside your function or within your function. So we don't actually change your code, but if you can invoke us, like import us as part of your code, we can instrument the function or get a hold of the old operation system, or like, let's say, the container running by the service provider, and then gives you a visibility there, so we can stop malicious traffic, and we can see if the function is overprivileged. We can see if the function suddenly tries to connect to a paste bin or anything that we suspect that is different. We also learn, as I said, fine-grained. We also learn the behavior of each function, so we can actually profile it and see that it needs to do only a certain thing. But let's see now how an attack or a serverless attack would look like. So we have like a setup here that is a Slack channel, right? So let's say it's a sales Slack channel or anything like that, or support Slack channel, and the user interacts with it. When the user writes a message into the Slack, it goes to the Slack API, and this is how I configure the application, that it will go to my API gateway. So if you look at number 3 here. So the API gateway is the trigger for the Lambda function, or the start of the process of this application, which what it is a serverless or a Slack chat bot. So when you type a message, this bot tries to understand what you're talking about and to respond accordingly. So I have there, after the bot understood, or let's say decided how to reply, they write everything to a DynamoDB database, just for the record, and then sends it back to Slack, which will appear eventually on the Slack channel. So let's see. The attacker can come here from the Slack, of course. This is the Slack channel, but it can also send requests directly to the Slack API or directly to the API gateway, and we'll see how that goes. Right, so the attack steps are going to be, first I'm going to validate the vulnerability, then I'm going to extract the source code, which is found in serverless, read some environment variables which usually hold the security or the secrets for your application, impersonate to the function, and then steal some stuff. Right, so let's do that. Sorry. Yeah, so here is my Slack channel, and there is a Slack bot behind it, and I can write to him, and you should reply everything. Our conversation is going to the database. Right. So first thing first, let's just see that it's vulnerable. So what we have here is a function that the code is okay. So there is no security gaps in the code itself that the developer wrote, me, the developer. But I imported a dependency that has a known vulnerability. So I used node serialize library. I did not write a bad code. I just imported this library and I used its function, its methods, right? But the code of the library is vulnerable, and it allows you to write code and run them inside as a function inside the code. So, and the function, oh, yeah, I'll show you that. It would be easier. Right, so I have a function. Yeah, this is the one. Right, so I have a function and I have a vulnerable dependency, which is node serialized in the version, but, and we'll get to it later, the function also have an excessive permission role, which is DynamoDB wildcard. As I mentioned earlier, the wildcard allows us to do everything inside the DynamoDB, right? So after we know these two facts, let's exploit it. So first, I'm gonna do, right. Just gonna launch an ngrok HTTP tunnel into my computer. Then I'm gonna take this subdomain. Forgive me for having these payloads ready for me. But you can find, so if you know that it's a node serialized vulnerability and you're gonna write node serialized in Google, you're gonna get this type of payload. So it's not that I brought something new here. And what I'm gonna do here is I'm gonna send this payload, which you can see here. What it does is require child process exec. So I'm gonna run a child process inside the function, and I'm gonna do eventually a curl into my computer, which is the ngrok that I just launched. So far, nothing related to serverless, other than the function is a serverless function. So when I send it, I got it into my computer. This curl request was launched from the container in which the function runs. So when I say container, I mean the serverless, or the serverless provider runs a container when you call the function, runs a container, runs the code, and then brings everything down, and you don't have to deal with anything related to containers. So just write the function, right? So first thing, I just realized that it's vulnerable. Now let's do some attacks related to serverless. So I'm gonna take the second one. And here what I'm doing is I'm gonna open another child process, same destination, my computer, only this time I'm gonna do a tar. So I'm gonna grab all the source code which locates in the current folder, apart from the node modules which I don't need, base64 wrap them, then tar.gz them, and curl them to me. Of course, there are hundreds of other ways to do that, but this is an easy one. So in serverless, the code runs, or the code is located inside the container, because the service provider takes this code, loads it into memory, and runs it. So this is how it works. That also means that if someone has access to your environment, then they can steal the source code. Fun. So yeah, I wrote this. This request came in. Victim source. Let's see what it has inside. So right. So this is the base64 wrap. I don't need that anymore. So let's just echo it. Base64 decode into victim tar.jz. Right, and then just open it. And we have the index.js. Cool, let's look what's inside. So this is the function code that runs in your backend, let's call it. So you can see that the file is protected with Protego solution. The reason that things weren't blocked is because the function is on alert mode at the moment. But that's not important. What we need to do is investigate the code now. Part of the fact that we now have some backend code, we can now trigger a more accurate attack against the function. So if we look here, we'll see the brain of the bot. In case it finds this, it will answer like that, etc. But the more interesting thing is that here we can see the function, or the part of the function that sends the messages back. So if you can see here, I have an an HTTP request to API chat post message of slack.com. This is the port, and in order to respond to the right channel, we have all these environment variables here, which are the channel and the text itself, and then the bot token, and then the bot user, and then the icon of the bot. So these are all nice. I cannot steal them because they are environment variable. Well, I can, but not like that. But I can, if I run the code inside the context of the code, then I can just use them. So what I'm going to do here is that no more curls. The function writes into the Slack, right? So why do I need curl anymore? So what I'm going to do here is I'm going to have a third payload. Here I'm not going to use a child process because I don't need that anymore. What I'm going to do here is I'm going to do a require HTTPS. So, and then I'm going to send a request to slack.com. So I separated them just because Slack would treat URLs in a different way. So it will go and bring the image like Skype, etc. So I just split them so Slack will not understand it's a URL, but it doesn't really matter. And then I'm going to use the same variables. So process env is the environment variables channel, and then the bot token, and then the user. And now I'm going to launch this, and you can see the icon here, right? This is the icon of the chatbot. So when I run this, I'm going to have a different icon for the Slack bot because I just switched the URL that the request will be sent with, and then I stole the original one. So I can do the same thing with the channel and get the channel, which is Slack chat. Channel, right. That's the problem. Slack chat, right, and the channel, and I can do the same with the username, which is also Slack chat, so it's not really interesting. But I can also do it with the token, which I won't, because I don't want you to copy it. So I'll set it with this. So till now, I read the code, and then I managed to exploit. So think about it like that. So now nothing really bad happened because I'm talking with my own chat. But if this chat, the backend, is a multi-tenant, now I can interact with different users and write messages to them. So if someone else installed my sales bot, my Slack chat bot, and I can steal their data. So now I showed you that the function has redundant permissions, which allows it to do anything on the database, which is the DynamoDB, while in fact it only needs a put item, which is the write, because the function only writes everything to the database. Why does it need a wildcard? It doesn't. And let's see how I exploit that. So that's going to be the last one for now. Sorry. Right, so this is the fourth payload. Again, what I'm going to do here is I'm going to do a require AWS SDK. So I'm going to use the actual SDK of the provider, require HTTP to send a request. And then what I'm going to do is I'm going to do a DynamoDB. So this is part of the SDK, right? So it's a DynamoDB document client dot scan. The scan is actually just get the data out of the database. So scan everything. And the table name is going to be DynamoDB table, which is an environment variable. And then these things doesn't matter. And then I'm going to send everything back to Slack like I did before. And when I press this, I'm going to see everything out of the DynamoDB database, which is, in this case, we could prevent that if we could just give the function the put item permission. Then even if the attacker has done that, we could prevent that just by changing the permissions, right? It's just like any other application. If you can block the permission level, then even if the attacker tries to exploit it, it cannot. So we could do that, but we didn't. So we ended up with this. This is a type of injection attack for serverless. So the attack is not new. So everyone knows code injection, right? But the attack vectors are a little different because here you have few different vectors. So first, you can steal the source code if you're running the code. And the second is you're going to target, you're going to write a code that is related to your cloud provider. So if I want let's say I have a function that, right. It is funny. So I told them, don't interfere with the Slack channel. And they just replied, it would be funny if we did. Yeah, and that's actually funny. So, yeah. So in that term, I'm going to attack the function, and I'm not just going to write PHP code or something else. I'm going to try and write a code that will go and look for resources inside the cloud account. So if you have DynamoDBs or S3 buckets or SES, SNS, or any other resource like logs, etc., I'm going to write an exploit that's going to try and interact with these resources and then steal them, just like I did here with DynamoDB scan, right? Okay, let's go back to the presentation. How are we on time? Oh, we have plenty. All right. Right, now that I know how to interact with the Slack, I don't actually need to go through the Slack. I can actually just curl to the Slack API, but it's nicer like that. Right, so we see how we stole it. Okay, so this was something called event injection. I showed it. It was partially API gateway, so it's kind of a way that you understand. But as I mentioned earlier, you can trigger functions with nothing related to an API call. So this was a REST API to our API gateway. But if a function is triggered for every email that is received, it's enough that I will send an email, and it will trigger the function. Now, if the function doesn't do any validation on the code, and it has some vulnerability, maybe I can, I don't know, attack your function through the subject of the email, which is new, and it can happen. And I haven't seen it in the wild because there isn't much of in the wild at this moment, but I'm pretty sure we're going to see it just like we saw on every other technology that came in. Someone said, oh, nice, mobile. Now we don't need to deal with security, right? And then we had it all over again. Fun for us. So it's going to be pretty sure the same for serverless. They're going to do, oh, even better. Oh, now we have the serverless infrastructure. We don't need to deal with security. And then we end up with this. So the first one is event injection. Again, it could be, maybe this is a good scenario that you probably saw somewhere where you interact with an application that allows you to upload file, and you get a URL to upload a file to an S3 bucket, to Amazon S3 bucket. This is very, very common also before the serverless. So if let's think about that. If the bucket itself is configured insecurely and is open, I mean, anyone can upload them. I can maybe upload files, which will, if malicious files, which will trigger your functions. And I wrote a few example blogs about it, how you can write malicious code, or even in the file name. If the function takes the file name and the file name is malicious, you can actually get some cool attacks like that. So I'm gonna go through some different attacks that we have in serverless. They're not specifically the first top 10, but we're trying to establish that now. I'll mention that later. So another big issue that we have with serverless is that, every function is about, from what we saw, is about from 5 lines of code to 300 lines of code. This is the average. So 3 is because it calls some other function. So it's just a wrapper or something. So let's say something between 20 lines of code to 300 lines of code. That's it, pretty much what each function does. But in order to be able to do that, they need to bring out a lot of dependencies with them. Because, right, you cannot really write, so it's stateless, so you cannot just get something from another way, but you need the functions to be able to do this. So you bring a lot of dependencies into your function, your application, and every function uses them. This is a very big source for vulnerabilities. So there are companies that does this vulnerability dependency check, like Sneak or Black Duck, which was acquired by Synopsys, and White Source. We also do that, but there is an open database, so the NIST database that you can use. The best way is to automate that, of course. Open resources. So as I mentioned, if an S3 bucket is open and you haven't figured it out, someone can trigger your business logic or your code without you knowing. And this could be, apart from the fact that if your S3 bucket is open, anyone can just download the files that in it. They can actually run code. And let's see, you probably know Showdown for IoT, that you go and search for Open IoT. So fun thing is there is one for cloud storage. So you can, it's called Gray Hat Warfare. And you can just go through thousands and thousands of open buckets, people that either that did it intentionally or not, and you can go, it goes like without limits. All right, so you can just click on one, and if there are files inside, let's take another one. Ru is fine. So you can see all the files inside, right? And you can just download them. Some of them are not, some of them are not there anymore. Some of them are not sensitive. But I just happened to, this is a demo bucket, find some very funny and not funny files open. Okay, so we don't know what's inside, but it's like Showdown, so you can try your luck. And there are hundreds of them, or sorry, hundreds and thousands of them that weren't supposed to be open. So this is a big problem. Also, there are ways to do, if you open an API, REST API, you can, so the default of this REST API is without any authentication. So it's good if it's just an informational application or something, but in many cases you just build up a function, and deploy a function, and the default state of it is it's open, no authentication whatsoever, and anyone can trigger your functions. So you need to be aware about that as well. Overprivileged function, this is a very, very big issue here that we saw what it can cause. But the biggest challenge here is that, so yeah, we can really fine-grain it. So you think about it, if you can really make all your function this list privilege, it would really, really decrease your attack surface. But how do you do that for hundreds and thousands of functions? And you don't expect the developers to own the permission. I mean, maybe you do in your organization level, but usually developers has no idea of what security is, and this is why it's so fun for us. And then, how do you deal with it? So again, we believe you should automate it. Part of what we do is we scan your code and we see what our API calls, like service provider, SDK API calls you are doing, and then we match it with your permission, and we say, hey, you only write to a DynamoDB, why do you need the wildcard? So the only way to do it is by automated. Sensitive data exposure, it's not new. Everything that is in the cloud is prone to, the data is out there, so you need to be aware. Again, sensitive data here will be a little different. So for one fact, the source code is inside the environment, and you don't want people to steal your code. Oh, another thing is that when the function goes up, it's a read-only file system that you don't control, but there is one folder, is the temp folder, which is the write, has write privilege, so the functions can write into it. So most of the data is written to that file, that folder, and sometimes people think, hey, I also said that, right? So the function goes, write something to the /temp folder, and then the container dies, right? Theoretically, yes, but, and someone back then validated an NDA for that, but they don't. They die, and then in order to keep your performance level like high, to give you a high performance level, they are not really dying, and they're just waiting for someone else to call your function, not necessarily the next one, and randomly land there. So you cannot control who is going to land on that container, but someone will and might. Not if your function doesn't run for a while, that eventually it will get killed, but if someone is not, if your function is, or your code is triggered more than once in 4 minutes, then someone will land on the same container, having the same file that you left behind, and maybe steal them. So you need to do some cleanups after your function runs. Right, denial of wallet against denial of service. So the attack here is different. Right, the attack here is different. So denial of service, you don't really attack the infrastructure, right? So I mean, if someone attacks us, our application, they really attacks the infrastructure provider, so AWS or Azure. So we don't care about it, right? But in order to prevent denial of wallet, because we pay for each call, right? So someone can just call, I don't know, unlimited loop our APIs, and we are going to pay maybe a few tenths of a cent for each, but eventually it can grow up. So in order to prevent denial of wallet, what we have, the service providers allows us to do either a budget limit to the specific function or account. So if it reaches $100, stop it. Or if you want, you can have a limited concurrency for your function. So you can say, I want only 10 parallel calls to this function, so I won't have a denial of wallet here. But then, of course, it's a trade-off, because someone can just trigger your function repeatedly, and no one else will be able to use your function. There is no real solution for that. Execution flow manipulation, as I said, the attacker can come from different ways, so they can actually bypass part of the application flow. It's more complicated now, so show you later how to interact with that, to read about it. Insecure shared space, as I mentioned, the /temp. Insufficient logging and monitoring. These are just part of the top 10, the original top 10, and there are logging and monitorings of the cloud account, but they are not they can be visible to you, but you need to know how to get them. So it's not like someone is attacking your service and someone will say, hey, someone is attacking your service. No, you need to go over logs like SOCWhile or a type, or use other solution, like us, and then see that someone is actually attacking your functions or your application. And insecure secret management. As I said, if you put secrets into your code or your environment variables, and someone can exploit your function, they can steal it. So you can maybe encrypt them. So this is another way to do that, or you can use some other vault-like solution that brings your secrets in runtime. Right, that's it. What you can do about it. So first, of course, don't panic. We talk a lot about it. We really, actually, after all this talk I showed you, yeah, it's not secure, but we actually believe that serverless could be the most secure infrastructure for your application. Our solution is also serverless, 100% serverless. And I mean, think about that. You don't need to invest in operation system and patching or operation system security or patching on anything. You just need to be able to write secure code. So yeah, security goes a long way, but you can limit it to secure code. And then I write a lot of blogs and webinars, and I'm doing about how to attack and how to defend serverless applications. So you can read about it. Just launched recently, Serverless Top 10. We just released our first draft last week, or this week. The first draft, what it does, it goes to the original OS Top 10 that hopefully most of you know. I go one by one and I show how they differ when we go to serverless. What are the new attack services? How do you identify security issues? How do you protect against it? Because it's different. I showed you one example. So the attack vectors are different, and the defense mechanisms are different. So if you go and look and try to compare, you'd see that almost none of them are the same. So same application, but different techniques, different attacks, different defense techniques. Right. Thank you, everyone. Any questions? Yeah. Yeah, so depends on your service provider. AWS will allow you to integrate their API Gateway Firewall, so you can use that, but it's only for API calls. And yeah, if this is the question, if this is the question, then yeah, you can use API Gateway Firewall for that specific. Not all the service providers are having that, has that solution, and it all. Yeah, so there are a lot of problems. Sorry, one second. A lot of problems with Google GCP. Also, for example, their current, and they're going to change it soon, but their current permission roles is one per application. So no matter what you can do, you can only give them one permission to all the functions in your application, and they're going to have to all the abilities of all the rest of the functions. So, AWS is one step ahead of them, but there are and keeping up with them. Yeah, one second. Yeah. We are. Sorry, I'm not sure I understood the question. I also have deaf, so. Yeah. It's not possible unless your whole application is really, really small, because they are limited in terms of how long they can run. Each function can run up to, depends on the service provider. It was up to 5 minutes. Now it could be, AWS just raised it to 15 minutes. Probably they're going to increase, but I'm not sure this is the right way to do that if you're going to use serverless. Yeah. Sorry? Yeah, what about it? Yeah, of course, you can use source code static analysis, and then you can fix your code. But again, it will really limit your, it's just like any application. Do you think that if you run checkmarks, which is very good about source code static analysis, is gonna make sure that you have no security issues in your application? They can help, really. I'm just not sure that it's the only solution. You have to do other things as well. Yeah. All right. No. Yeah.
So what kind of controls you can have on the injection?
Okay, so there is no standard. Again, if you're using only API gateway, which is, it's kind of common, but not for new companies that go there, you can use their solution, their API firewall, API gateway firewall, but behind that there is no other solution. If your function is called from other things, there is no solution that the service provider will give you. You need to either, in your code, make sure you know what you're doing, so validate it, or run a solution like we provide, which protects your function at runtime. Yeah. Sure. Yeah. I mean that, let's say that someone is trying to do some injections or attacks into your functions. How do you get that from, you don't have a control that, I don't know, looks for patterns over the networks because you don't own it, so how do you know it? So you have few ways to do that, and the easiest one would be probably, easiest technology-wise, maybe not easiest like in doing that, actually doing that, because it's gonna be tough to find it. It's going through the logs that you have log services. So the cloud provider has log services that they give you, and by default, every function that you write automatically writes to its specific log, and you can then go to the log service and then try to find out that someone attacks you. But it's hard to do it in real time if you have hundreds and hundreds of functions running and invoking repeatedly. So how do you find it? So you don't find it. So you need someone to give you this insight. So there are other solutions. We're not the only one, but we're the best. Any other question? Thank you, everyone.